One of the files, as you might guess, is the text files, which is the instructions, and then the other text file contains some starting source code. Let's eyeball the instructions first. I'm going to paste this into a Word document, which I should have done in the first place, eh? Okay. Okay, homework assignment, whoops, not 5, 8. Step 1, open the instructions. Whoops, there's another 5. You can see what I mean by it's out of time. We should have done this one several weeks back. But hopefully that means it'll be easy. Open the assignment 8 instructions text file, copy and paste its source code contents into a new C++ file. You know what, we could do this one as an in-class assignment, I think. 2, inspect the program, run it, inspect it again. Understand how it works. Step 3, modify get scores so that it will display the average along with the total. This function is commented as fix me. Addendum. Note that the program uses some techniques we haven't discussed in class yet, specifically character arrays and the ampersand parameter operator. We just mentioned ampersand. We got our first hit of that on last Wednesday. That's when you pass something in by reference rather than passing in something by value. Okay.
Was a character array like, one time I wrote a base 58 encoder decoder, and it's like the string of characters that it lists as like in order of what it converts to from.
Yeah, yeah. That's a C-style programming is characters array before the inventions of this 20 different string classes that you have available to you. Microsoft's variants and Unicode variants and stuff like that. Okay, so let's open up, and I think we ought to do this one as an in-class assignment. Open up the other text file, the one that says source code. Take its contents and paste it into a new project, Visual Studio project. Alright, so this has those instructions that were in that other file right up here at the top. Paste this into a code, inspect it, go add something to the fix me that will display the average along with the total. Okay, program description. The program reads the username from the keyboard and a series of scores from input, so it's going to be using CIN. When a score of -1 is entered, the scores are totaled and displayed. Then a new username is read and new score is read. The program exits when stop is entered as a name. So stop's going to be our sentinel value. You remember what a sentinel value is. It's a special piece of data that is not treated as data. It's treated as a command to cause the program to do something, usually exit a loop. So let's see. I have a note here. Rather than using namespace std, we will just use the specific objects this program uses. So here's an alternative to doing using namespace std. Is up at the top of your program, you can list the specific objects you're going to use out of the std library. Is there an advantage to doing that? Well, a lot of people do not like to include, add the statement using namespace std. And the reason for that is that the std library, the namespace, is a grab bag full of a whole bunch of different definitions. And people think that it's got too many things in it and that, you know, you'll wind up with inclusions that you weren't expecting. So one recommended programming technique is to not use any namespace at all and to just always precede your CIN and your COT, your cout and stuff like that with std all throughout your code. The other is to just add the using keyword followed by the specific objects you're going to use. And that's the way this one works. It's using some stuff we haven't used before. I don't recall us using an iStream. Could be wrong about that. We've certainly used CIN, cout, string, and end of line. So functions for prototypes declared later on. Apparently in the code we have something called getline, which takes a stream. This is getting us to the point where we're going to do file I/O. Because I've told you that we keep doing these stream operations where we read the keyboard as though it were a stream of characters. If you open a file as an input stream, you can read from a file just as easily as we've been reading from the keyboard. So this I stream is we're going to feed it, CIN, and that's where it's going to read from. But later on, we can modify this program so that what iStream is it's a file object, a file stream. So we have two prototypes here, one called getline, which is just going to get a single line of data. Honestly, I don't remember why I implemented my own getline rather than using the one available to us in CN. But, well, it'll be interesting to go look at it. And then the next one is getScores. And what getScores is supposed to do is it's supposed to open the file, or at least read let's go down and look. Main entry point for the program. Asks for the name, and then calls the getScores function to read and process the scores for that username. The program exits when stop is entered as a name. So it's going to loop over and over and over. And while name is not equal to stop, we ask for the user's name, the person's name. We get that name as a line. Why didn't we just use CIN? Because that would only get the first name. And what if that person has 20 names? Donald J. Trump 3, whatever. We want the entire line full of data. So that's why we're using this getline function up here. And I know that there's an equivalent CIN function that I should have used. We'll take a look at what getline does in a minute. If the name that they typed in was not equal to stop, we call the getScores function. What does getScores do? It lets them type in a series of values. And then when they type in -1, it exits. It bails out. Once they type stop, then this while condition is no longer true. It bails out of that outer while loop, prints, okay, all done, then returns. Scroll down past getScores and then come back and look at that in a minute. Getline. Getline, this function reads a line of data from the specified input stream and returns it as a string. We use this because CIN into variable will read only one word of data, and a name could be several words long. Now, like I said, I know that there's a variant method of CIN that will read in an entire line. So, why don't we just find that, and maybe we're going to replace that whole function with that. CIN get entire line.
Were you anticipating me saying that?
Yep, I'm psychic. Here we go.
I've been focusing almost entirely on parsing binaries, so I wasn't aware of it. I'm almost done with the thing I was going to show you, though.
Yeah, there's the way to replace that. First, I'm going to run the program, make sure that it does something before I start hacking that getline method out of it. Let's run it, rebuild the solution, run it without debugging. All right, enter the person's name, Donald D. Duck. Enter a series of scores, 100, 200, 300, -1. Enter a series of scores with spaces, ending in -1. Okay, I entered them all at once, and so that was keyed into the buffer. And then the total for Donald D. Duck was 600, which is appropriate because 100 plus 200 plus 300 is equal to 600. Enter the next person's name, M. Mouse. Enter a series of scores, 10, 20, 30, 40, -1, that should be 100, and then enter stop. Okay, all done. Now let's try excising that getline function out and just using cin.getline. There has to be a reason why I did it like that, but I cannot recall. And that was several years ago that I wrote this assignment, and I've slept since then. Let's see. My wife moved here from Michigan, and she always thought that that was an obnoxious phrase. Why do Oklahomans say, I've slept since then? And I say, it's a joke. She didn't like it. Okay. So up here inside of main, where it says name is equal to getline, instead do this. Getline, parentheses, CIN, comma, name. And we better remove the prototype and everything for getline. But this getline is all lowercase, unlike my method. Now I'm going to comment my call to my own personal private getline method and just leave this one. This one is the canonical C method. Or function, I should say. Not a method. CIN should have a method that does this rather than there being a function that you pass the CIN object to. Enter the person's name. Lefty Louie. Enter a series of scores. 10, 20, 10, minus 1. Okay, so that worked. There's absolutely no reason for that getline function. And I don't recall getline down here even using character arrays. Oh, it did. Look at that. Getline has, it declares an array of characters with a set length of 256. And by the way, this is very bad programming because what would happen if the user entered more than 256 characters worth of data? That sounds unlikely, doesn't it? But hackers, crackers, deliberately try to feed more data than your program can accept to generate buffer overruns so that they can insert, code into the memory space of your program. So you're not supposed to use character arrays with fixed length limits anymore. You're supposed to use something more elegant. So this function, in general, is just a really bad idea. We're going to nuke that. Delete the entire getline function and its comments. Also, go and delete the prototype up at the top. And there's one more change I would like to make. I don't like it saying enter a number or -1 for every number that you type. So I'm going to move that cout statement. This is inside get scores. I'm going to move that cout statement that says enter a line of scores above the while loop. We really only need to tell them once that they're supposed to be entering scores. Now let me make sure I did not break my code, and then I'll wander around and make sure that y'all got the same stuff going on. Jimmy Webb. Enter a series of scores. 1, -2, 3, 10, 20, 30, 40, -1 to bail. Total for him is 102. Not that I can add that together in my head, but I trust it. Yeah, that looks right. Okay. No, it's not.
That's correct.
It is correct because the -1 is not data. Okay. All right, and then type stop, and it bails out. So my getline function is an example of reinventing the wheel. If there's already an acceptable function in the library, you're much better off using it than recoding it. And that's especially true when you start using stacks and arrays and other dynamic data structures, when you need to hold collections of data. There are very well-tested libraries for doing that stuff. And when you go to a four-year college, they'll make you in a data structures class write your own implementation of a list and of a hash table and a stack and stuff like that. But then when you get out in the real world, you're not supposed to do that. You're supposed to use the ones that are already a part of the library. Increase your productivity 100-fold then if you don't write everything yourself. All right, everybody get this working so far?
Okay, thanks. Thanks for answering that question, John.
Yes.
John, it's so cool.
All references to getline.
I'm just kidding. Oh, you wait, you graduated.
Yeah, so what was happening is it was slipping the point where, filling in
I
the
think I just fixed it on accident. I wasn't even paying attention.
We asked for it, but we didn't let it type in.
No operator found which takes the right hand operand of all recording. Sorry.
Did you mention one of my personal lords and saviors, the Beatles?
I said Paul McCartney, but I was really thinking about the
I guess
quote
it
of Paul
counts.
McCartney that they made in a science lab in the '60s, like took over his life and assassinated him.
Yeah,
What did you use to replace the getline function?
I'll show you. Sorry, I should have left that on the screen.
C++ has a getline function that the first parameter is the input stream, CIN, and then the second parameter is a variable that you want filled in. You know, I probably did that just to give an example of reference parameters.
We don't say name equals, we just do like a get line and then in parentheses blah blah and semicolon. Oh, never mind, you have it up on the board. I'm reading.
Right.
Yeah.
Once you get it going this far, think about what you're going to have to change in order to calculate the average. Besides the total, what other piece of information do you need to have in order to calculate the average?
The number of
Yeah, the number of items. So go down to get scores and figure out how you would keep a tally of the number of items. Now that we've deleted, or will delete line function, we'll use the C++ variable, which is
what the game is.
that's like it.
Did you feel bananas? It's a very bad student. Phil Bananas is a bad student. Bad boy. Phil's bad. Nobody in this room is named Phil, right? Okay, cool. Phil in the future.
This is out.
Isn't there a way to count the number of
That order?
numbers? Do you want to calculate the alphabet?
Yeah, if you just put it all in that one.
Pardon me?
Are you calculating the average now?
Yeah, that's what you're trying to do, is modify to calculate the average, and I'll help with that after I make sure everybody's got it going. All right, y'all are all good? Okay. Anybody? Yeah, we don't like it printing this over and over and over, but that's probably the valid sum. 100, 120, 150, 200, 200, 390. So it did work correctly. The only thing we want to do, and it's not your fault, it's the way the program, is go find that print statement and move it above the while loop so that it only prints it once. Really don't want to print out
gonna be the
No,
one,
no,
and I'm gonna be like,
You can double it to 100 if you wanted to, but everything else is on to
This one have to go
a while. Nope, because that's inside the while. We want to keep asking to repeat the over and over.
No, you can't do that.
Only going to tell it once. So
What?
it's happening. If I will see that message over and over, if you type them all in, that's my
I can't hear you.
So just count the red one, it will iterate through the while loop again and then print that message again.
See, this is what he just said.
We have more data waiting in the buffer.
He said, I can't be the greeter at Walmart because I'd have to pass out dot, dot, dot.
That's all you changed so far on it?
Yes, those are the only changes. Everybody else got it going? Wave your arms in the air like you just don't care. You need help? Okay. All right, so now I want to calculate the average. In order to calculate the average, I have to know the number of grades that they entered. So inside of get scores, in our while loop, we need a counter. And we need to iterate that counter as long as they don't type in -1. We're going to have a problem if they enter -1 and then divide by 0, but oh well. I mean, you know, if they don't enter any data at all. But we can try to fix that. Okay. Oh, what do you know? I already have a counter up here. I've defined a counter, but I'm never actually incrementing it. I am incrementing it. Wow. The program's already written. Don't tell me that we're already calculating the average, too.
No, you're not.
All right, so we need to add two lines of code. All right, so in that if statement, if counter is greater than 0, why are we checking to see if counter is greater than 0? Because we don't want to divide by 0. If they didn't enter any data at all and then they just hit -1 as their first piece of data, then if we try to calculate the average, we would be dividing 0 by 0. Oh, and I don't know if y'all have ever seen what Siri does if you ask her what 0 divided by 0 is. What is 0 divided by 0?
Imagine that you have 0 cookies and you split them evenly among 0 friends. How many cookies does each person get? See, it doesn't make sense. And Cookie Monster is sad that there are no cookies. And you are sad that you have no friends.
I think it found Uncyclopedia. I think it's reading from Uncyclopedia.
Yeah, I've never seen Siri just throw down and insult you like that. I don't know if y'all can all hear that, but she said, and Cookie Monster is sad that there are no cookies, and you are sad that you have no friends. Okay.
That was either Urban Dictionary or Encyclopedia. Had to be.
Okay, so here we want to print the average along with the total. So at the bottom of get scores where it says if counter is greater than 0, that's our print statement. That was already there. But now let's calculate the average. We've already even declared the average variable up higher. So average is equal to total divided by counter. Ooh, it's underlining average. What's wrong with that? Average is undefined. I thought I saw that up here. Nope. Okay, let's declare it. But let's not make it an int because, you know, we might want to display some fractional average. Let's make it a float or a double. And now let's print that out. Average for, and we can give the same name, or we could tack that all on as the in the same cout, but let's do this in 2 statements. So the average for name is average. So I shouldn't have covered it up while I was testing it. Right. Okay. That seemed to have done it. So that meets the requirements for that assignment. What would be more interesting now is if we made it read from a file. That would be a problem for Solomon unless you've cracked that difficulty in finding where it's saving text
I didn't
files.
get the email.
You didn't get it. Did you check your spam folder? Yeah, check Gmail spam folder. There's a lot of Brightspace emails are being redirected into spam. What you're going to have to do is you're going to have to specify a fully qualified path to the file name in order to find it. Okay.
Is the default redirectory on these computers really weird?
On the Mac, when you're using Xcode for development, it's going in some crazy subdirectory that a lot of people think that it shouldn't go into. And it's one that's protected so that by default, the searches don't find it. And yeah, it's crazy. I love the look of horror.
That's not adjustable in the configuration?
You
Like
can-
XP GUI?
You can tell it Xcode to produce production code rather than debugging code, in which case it will save it somewhere else.
You
And
can't-
so,
You can't give it a new default like redirectory in its GUI interface? Like
No.
tell it to
but you can give it a valid path when you're creating the file, you know.
stream on Google. Google makes Xcode, right?
No, that's Apple.
Oh, it is?
Yeah.
Oh, for some reason I thought Xcode was associated with, that's right, Xcode's like the iOS stuff.
Yeah.
Shame on Apple.
iOS and GCC, you know, the GNU version of C++. Alrighty, well, if you've got that going, go ahead and upload it into the Dropbox. I need to modify the assignment a little bit to reflect that we've taken getline out. Be right back. Be right there. I'll lose track of what I'm doing if I don't do it right. Okay. Now this is actually fairly important in terms of object-oriented programming. Overloading functions. Now that sounds bad. You know, I can just hear Scotty telling Kurt that, you know, he's been overloading his functions. But no, it's a good thing. Overloading functions is when you write a function that takes different kinds of data types but has the same name. And the reason you do that is to make that function flexible so that not only can you handle floats, but you can also handle strings or sphere objects or whatever kind of data that you think that that function needs to be able to implement. So the way you overload a function is you just write one function and then you write another function that accepts a different data type. And then if you want to overload it again, you write another function with the same name but accepts a different data type. So overloaded functions have the same name but different parameter lists. They can be used to create functions that perform the same task but take different parameter types or different numbers of parameters. And the compiler determines which version of the function to call. And the way that it does that is it inspects the number of parameters that you are passing and the types of those parameters that you are passing when you invoke that function, and so it links it to that function at that time. So here's some examples. He's written, or she has 4 different prototypes here. All of these are a function called getDimensions. I don't know what getDimensions means if you only pass in one variable. I don't know quite what they're trying to tell us here, but you could, when you call getDimensions, you can pass in either just the length, or you can pass in a length and a width, or you can pass in a length and a height, or you can pass in a height and a base. And for some reason they've decided that length and width are declared as integers, and that base and height are declared as doubles. And that's the only way that you could distinguish between those. So this is kind of a lame example, but it shows the point that you can write a function, and this is the prototype, not the function itself. It accepts an int. You can write another function that accepts more than one variable. Let's do that. maybe just tack it onto that code that we already have open if you haven't gotten rid of it. Go down to main, and right above main, we're going to create a couple of functions. One is going to be, it is going to be called add. And add is going to take two variables, int x and int y. And what does it do? It returns x plus y. Now write another version of add that takes three variables, int x, int y, and int z. And it returns x plus y plus z. And then we realized, oh, we should have made it so it handled floating point numbers as well. But ignoring that, we have two different versions of the function. They have the same name, so they look like they're going to work the same way, but you can pass in different amounts of data to them. So inside of main, I'm going to do this. Cout add 1, 2. That should print 3, right? And then next, cout 1, 10, 100, and that should print out 111. That's giving me grief. Oh, I put a comma between the word int and the variable name x. Okay. So this is overloading. We have the same function, but it accepts differing numbers of parameters. You can also, besides differing the number of parameters, you can modify the data types. Like we could write a version of add that took doubles rather than ints. Or we could write a version of it that took string versions of numbers and it converted those numbers into, numeric values in order to add them together. You can go crazy with overloading. And one thing that people tend to do when they get the concept of overloading and they're starting to, once it clicks, is that they start overloading more than is necessary. They think to themselves, oh, I better make an add function that accepts strings and as well as numbers. And oh, well, maybe it should accept character arrays as well as strings. And so you write a whole bunch of different versions of it, even though you didn't need them at the time. Just because you want to write, a thorough implementation. You don't need to do that. If the opportunity does not come in your code to make use of that function, there was no reason for you to have written it in the first place. I'm going to test this. I want to see it print out 3 and then 111. It did not. I got build errors. However, it's not telling me what the build error. Oh, I already have.
Commas instead of semicolons up in your function. I can't remember that word for some reason every time I try and say it.
Okay, that code worked. The error I got was that I already had. I never closed my last executable, so when it made a new one, it couldn't write to it. Now I didn't understand your question.
Never mind, I was wrong.
Okay. So that's function overloading. Let's see if he has any better examples than the one we already looked at. Using function overloading in program 627. He has a version of a function called square. One version of the function square takes an integer and returns an integer, an int times an int. Another version of square takes a double, and it multiplies that double by itself and returns that. We could do that just as easily as he did. So underneath my add functions, I'm going to add 2 more functions. One is going to be one called square. It takes an int, and then it returns x times x. And then another is a double. So it's going to return a double. So the syntax for this one is double square. And then the parameters of type double, and it returns x times x. So now we can call x, heedless of whether we're giving it an integer or a floating point value. I'm going to kind of squish my code down so that I can get more of it on the page at once. Okay, so I'm going to add two more C outlines to main. One is going to be the square of 10. And then one is going to be the square of, I don't know, of 5.5. No, it's 0.5, because 0.5 squared will be 0.25. So we'll recognize that. All right, and that worked. 10 squared, the integer 10 squared is 100. 0.5 squared is 0.25. And so we have two versions of the function in operation. One of them takes an integer, the other one takes a double. So your functions, if you're going to overload them, have to differ by the parameter list. You can't use two functions that have the same name, the same parameter list, and then differing data types. You know, like if you made one version of int that took an int but returned a double, and then another version of square that took an int and returned an int, how would it know which one? You know, because it's accepting the same data type. So the function, the parameter list, the parameter type list has to differ between your functions when you overload them. So in this case, it works because integer, we have one integer here and we have one double there, so our parameter lists differ. In this one, add accepts two integers and this one accepts three integers. So again, the parameter lists differ, so those are valid. Here's something that would not work. What if I decide I'm going to change the parameter name but use the same data type? So I'm going to make another, don't type this one in because this is bad code. I'm going to make another version of square that takes a variable called d rather than x and returns d times d. That's bad. It will not compile. Oh, fine. Oh, good. It generated an error. And what it's saying is that double square parentheses double already has a body. The reason for that is that as far as C is concerned, these functions have identical declarations. Because if you make prototypes for them and you leave off the variable names, you'll see that they're identically declared. So when you're making a prototype, you don't have to put the variable names. You can make it look like this: double, square, followed by the word double, and then followed by a semicolon. There, now I have prototyped that one. I could also do the same for the integer one. Double, square, no, int square. That takes an int. There we go. Now I have two prototypes. I'm going to put these together. Now what would happen if I prototyped this one down here where the variable is named d? What would that prototype look like? Somebody read it out to me, if anybody's been watching. Double, space, square, and then double. The prototypes are identical, so the compiler could not tell these functions apart. That's why this and this will not compile. It says that the method, the function that takes a type double and returns a type double already has a body. And that's true, it's declared there. This is the line that's getting the error. So if I go to my error list and I double click on the line, there we go. It's going to that one. So overloading. What is overloading? Somebody reword what I said. Even if you don't get it right, it's okay.
You declare and write more than one function of the same name that can take different kinds of input, right?
Exactly, right. Functions with the same name, but different parameter lists. The overloaded functions must not have identical parameter lists. Why would they? Because they just make a mistake.
They want to make a mistake.
Not if they want to make a mistake. People just make mistakes. Yeah.
You're going to declare apple and you put oranges into it.
Yeah. It's just a situation that the compiler cannot handle. So it's not that anybody would want to do it. It's just an error condition for the compiler. Oh, sure. Sorry.
The power you
I'm going to remove these prototypes unless you just like seeing them, because they're stopping main from showing. There we go.
Oh, yeah. Well, they have been some shoes under.
The exit function. We've seen the break function, right? The break function will bail out of a while loop early. Well, exit will not only break out of the loop, it'll break out of the whole darn program. It'll kill the program. So if for some reason halfway through the process of the program you decide that the program needs to terminate, then you can put an exit in there. Usually used for abnormal termination of the program. If you want, exit can return an integer value, just like the return statement can. And then your operating system, your scripts, your bash script or your DOS bat files or whatever can query that, to see what the error code was. So it's really easy to use. You just put the word exit, and in between the, as an argument, you pass the integer. If you want, you could include a library that defines two exit codes, exit success and exit failure. Now I'm really curious about what those values are. So I'm going to go into that little code that we keep revising and do #include C standard library.
I think you have to include that no matter what if you have the exit statement.
Okay, let's see.
It was throwing errors yesterday when I was using it, so I added that. Yeah, I was right.
So after I print out my adds and my squares, I'm going to exit. I'm just going to exit with a 0. Let's see if it compiles.
Of course, I wasn't using Visual Studio. It might automatically happen there.
Well, you're right, it failed. Oh, that's because I never deleted that bad function. Try it again. Okay, so no, it did not give me a problem, but it's a good idea. Let's go add that as an import.
It would not allow me to in G++ yesterday
Huh.
without it. It's pretty weird. Not like your Alienware, posh Microsoft bloatware crap.
I actually got
Command line parameter development. So up at the top of my program, where if I ever find my include statements, I'm going to #include cstdlib. And the only reason I'm doing that is because before my exit statement, I went to print out those values that this slide is suggesting we return. So there's two of them. One is called exit success and one is called exit failure, and both of those can be used as parameters, arguments for the exit function. So down here inside of main, just for my own personal edification, I'm going to see out exit success and I'm going to see out exit failure. I'm kind of expecting to see that success is 0 and failure is 1 or -1, but let's find out. 0 and 1. Okay. So by convention, if you do exit 0, it means the program exited no problem, that it was not in an error state. It's just like putting return 0 at the end of main. And by convention, returning a value of 1 from your program indicates that there was an error. Now realistically, you could define a whole bunch of different return codes. That 2 meant that it couldn't open the input file, 3 meant that it couldn't open the database to write to, stuff like that. All right, none of that was necessary. I just wanted you to see the use of the exit keyword. Wherever you put exit, the program's going to bail out right then and there. If it's in the middle of an if statement nested 20 levels deep, inside of 3 recursive function calls, it doesn't matter. The program dies right then and there. Why do you do that? Well, if your program gets into a state that it simply cannot recover from, you may just want to not even try to handle those errors, and you may just want the program to abruptly exit. That's not really good programming. It's not really great programming. But if you're writing command line applications, and all it's supposed to do is produce a series of values to feed to another application, maybe it'd be okay just to exit right out of it if it gets into a state. Print some kind of error message, and then boom, the program dies, rather than having to trickle all those error messages back to main and then try to handle them. Still not the best programming paradigm. Let's see if the author agrees, or nope, he doesn't say anything about it. So exit terminates the program, can be called from inside any function you write. You can pass an int. The operating system can use that int to indicate the status of the program termination. There's no reason to use exit if your program is properly written and it's working normally, but you could use it for error handling, for abnormal termination of the program if it gets into a state that it cannot recover from. Oh, and you're right, this one says that it requires C standard library. We proved that it didn't, but then Microsoft is weird. Okay.
If they default encode or something.
So stubs and drivers. What is a stub? It's a dummy function. When you're figuring out the logic of your program, sometimes you just want to write the functions, the skeleton of the program, and not fill it in. And so, for example, if you're going to write a program that took input and then did some kind of processing on that input and then printed some output, you might go, okay, I'm going to break that up into 3 steps. I'm going to write a function called getInput. I'm going to write a function called process, and then I'm going to write a function called showOutput. So you go to your program and you go, well, okay, I'm going to create a new program. You do, file, new, whatever, and then you start adding some functions to it. These are called stubs because they don't do anything. Alrighty, so, I've decided that getInput is supposed to return a string for some reason. GetInput. Maybe it's going to accept a file name, whatever. We'll decide what it's supposed to do, but it doesn't do anything right now. GetInput was called. That's all it's going to do. And now I realize that my program has those 2 other steps. It needs to do process, input, and maybe that's one's going to return an error code, so I'm going to declare that as an int. Process data, and it takes a string that was entered as input. Again, we're not going to code anything. We're just creating a structure, a skeleton. It's like putting a frame on the wall with no painting in it. Process data was called. And then, my program, as I mapped it out to y'all verbally, took 3 steps. One was getting the input, one was processing the data, and one was showing output. Showing output doesn't need to return anything, because it's not like showing output on the screen is going to return an error code. So show output, and who knows what kind of data that's going to take in. Maybe another string. Okay, cout. Show output was called. Now this may look dumb. Why would you do this? Well, because you could flesh out, or you could develop a skeleton for your logic, not just 3 statements like that, but for a very large set of programs. And then you could, parcel out the development of this program to different people. You can say, okay, I need you to write the getInput function, and here's what here's the kind of input it's supposed to ask for, and here's what it's supposed to do with that data, how I want it returned. So while Kevin's working on that, I'm working on process data, and Solomon's working on show output. But at every point, our programs are still working, even if they're not doing anything except printing process data was called, and printing show output was called. So this is actually a useful paradigm. I kind of do that. You've seen me get up here and then I type a bunch of comments and then I go back and I fill in the comments. Same idea. Yeah.
Is string always not highlighted? Because it does that to me too.
Yeah, why is it highlighted as a parameter but not as a return type?
It does that to me in my text editor too, but it's not. I always wondered why it does that.
That's a very good question. I have no idea why that's not highlighted. These are highlighted because they are keywords. They are actually defined by the language. String is a class, but it's a data type, and so it ought to be highlighted just as much as it was there. Very good question. So these are stubs, 3 stubs. And so I could go down to main and I could call all 3 of them, Here's what my program's going to be. Get input, process data, check that out, it didn't, yeah, there we go. And then show output. Okay, and then exit, just because I don't want to run that stuff that comes after this. Build errors. Get input must return a value. Okay, very true. Even when you're stubbing programs out, if you define a return type, you have to return something of that type. What's the easiest thing to do would be either to return an empty string or a null. Null is kind of rude because if you tried to print that out, you wouldn't get anything. So I'm just going to return that. Or I could say, not implemented. Something like that. Same for int. We need to return an int. I'm going to return a -1. Good error code, whatever. Show output doesn't return anything, so I don't have to return a value. Now it should work. There we go. It didn't do much, did it? But it says get input was called, process data was called, show output was called. So why do you use stubs? Just like I said, so that you can create a skeleton of a program that you can then, you kind of map out the logic, you know what functions you're going to need to write. Now, if you just sit down and start freeform coding, you're probably not going to do that. But, if you pseudocode it or flowchart it or whatever to figure out the logic of it, then this technique works. I won't say that. I mean, you could stub it out, even if you're writing a freeform. There's nothing wrong with doing that. All right, we're done with that chapter. We've hit the end of our 9:45 minutes. So if you haven't uploaded your CPP file into homework 8, go ahead and do so. I'll just take attendance based on who uploaded stuff.